So node designing, data aggregation and routing. Now we comes to the communication protocols. So how we can communicate this data. Routing protocol is some sort of the algorithm. You can make the path. But for communication purpose, the communication unit is there. They use some communication protocol and we can use this communication protocol on that path like this. Now we continue communication protocol. So wireless sensor network, they support various communication protocol as we already seen that. Very well known is the IEEE 802.15.4 standard. So this is not only the communication protocol, this is the standard and the communication protocol is on the based on that standard. And this standard is designed for the low rate wireless personal area network. That means you need to transmit a very limited data and your personal area network is there. You can transmit your data in that case, and it works on the unlicensed industry, scientific and medical bands, ISM band. So this is the good that you are not required to pay any cost while you use this one protocol or while you use this standard for transmission of the data. So this standard, they specify the bottom two layers, that physical layer and the MAC layer. Upper layer is depend on your routing protocol or depend on your protocols, whatever communication protocol, but bottom two layers is definitely specify the physical and MAC layer based on the 802.15.4. And these two layers, physical layer and MAC layer, is of course the low power, low cost, low data rate supporting wireless communication networks. And good for wireless sensor network, industrial automatic, smart grid, healthcare and other things. And basic of the other routing protocols such as Zigbee, 6LoWPAN, wireless, ACR, all these protocols are based on that one 802.14. So here this standard, they use 2.4 gigahertz frequency and 915 megahertz, and this one, and they use the 250 kbps data rate. So this is the important point, very low data rate is there. Don't assume that you can transmit the video sort of. This is suitable for data transmission, a small size of the data. They support the DS3 and FSK modulation technique for modulate and transmission of the data. At the receiver side, once again they demodulate and they can collect their data like this one. And this is the beacon-based, beacon-enabled network. That means they support the beacon-enabled and non-beacon-enabled. Both type of, they have the support 15.4. Beacon-enabled network where periodically beacon frames to synchronize the devices and transmission of the data. That means periodically you can ping the data whether you are alive or not, whether you want or not, but that means you receive a data in a fixed period of that time. Non-beacon based, which is some sort of thing, the CSMA versus CD. Okay, multiple access and collision avoidance techniques are there and they can get whenever the slot is available, not every time or periodically beacon. So 802. They have the both type of facilities. It's up to you that what type of applications is there. Data rate is also 250 kbps is sufficient for transmission of the data, and the frequency band is the license free or free spectrum frequency band. You can use that one, and this spectrum is specially designed for industry, scientific and medical purpose. Now Zigbee protocol. So when we talk about the Zigbee protocol, that is based on the 802.15.4 standards. That means whatever the properties and the qualities of this standard 15.4 standard, that is already incorporated with the Zigbee protocol. That means they also consumes the low energy, low power consumption, low latency, and that means they also high reliable and the security. Why? Because that is the 802.15.4 based on that one. So they automatically capture all these things and properties are there. And they also support the flexible network architecture, allow to deployment and management of the wireless sensor network. And they support the 2.4 gigahertz because of that 15.4 properties. Application is whatever the industry application that we have seen, the healthcare applications is also there, building automation. This is a very interesting picture. Now, OSI model, as we already familiar that OSI model in the computer network, they have the 7 layers: physical layer, data link layer, network, transport, session presentation, and application layer. This is the Zigbee or 15.4 like this one. So, bottom two layers that we already said that this is the 802.15.4. Then after the network layer is there. Then they merge all these two layers, that presentation sensor layer, they can say the application interference in the Zigbee, and application layer is there already. Transport layer is some sort of security. So in that case, the changes in the OSI model and the Zigbee is at that level. These are the already you fix because of you use the 15.4. So you have no control in this. And here this Zigbee, they merge all these protocols together and make this type of architecture: layer 1, layer 2, layer 3, layer 4, layer 5, and layer 6. And these layers, 5 layers, that means because these are dotted, that means not clearly there are 2 layers. That is, they have the different properties, but that is only in a one packet sort of thing. So one bigger layer like this one, second layer, third layer, fourth, and fifth layer. 5 layers we can convert OSI model in the Zigbee communication protocol. Now the second one is the Bluetooth communication. Of course, Bluetooth that covers in our smartphone, and numbers of devices they use the Bluetooth. Why? Because they consume less energy, and they have the short range communication. You can communicate some meters sort of thing. Bluetooth developed in '94 with Ericsson company, and now it's widely used because of their low energy consumption and short range communication. And Bluetooth devices must be paired with each other before transmission. That is a very big thing. That means we can say good or bad, because positive point is that when you pairing, you can share the security and other things. So security and other things you can maintain. But the challenges is that pairing is required. That means that is a time consuming, and you are not able to connect the large number of devices, because one-to-one pairing is there. So some constraint is there. You can connect up to the 3 devices, or you can communicate only up to the, or connection up to the 8 devices. So if you want to go communication more than that one, then definitely you can break some communication links for the others in that case. So this is the cause of this one in that case. And that they also perform the better performance, security, power efficiency, and other things in the Bluetooth case. But the challenge is the limited range. Communication range is very short. Their bandwidth is also a one constraint. You cannot transmit a huge size of the data, and interference from the other devices comes into the picture like this. And now the Bluetooth, similar as the previous one, Bluetooth also have the application layer and Bluetooth stack layer, and this is the, that means radio layer, this is the make layer sort of thing, and basement layer, physical layer like this one. So application layer is responsible to connect the Bluetooth with their application, whatever the applications are running. So it works as a sandwich between your application, whatever the Android application is there in a smartphone, and your Bluetooth device. So intermediary application layer responsibility is there. Complete Bluetooth properties, whatever the Bluetooth architecture or Bluetooth is there, they work in the Bluetooth stack layer. They have the capsules, or we can say they have the functions of the SCL, host control. They control the devices. They maintain the link management protocol for maintaining or connection the link establishment, logical link control and adaptation. L2 cap is there, and DSP is there. So these 4 part of those 4 sub layers, they are completely worried about how to connect, how to manage, how to transmit the data, and all other things. Now make layer, that is responsible, radio layers, that is responsible for frequency hopping, spectrum, how to change the format of the data and transmit the data from physical layer to the upper layer. And last one is, of course, that is the modulation technique, error control, error condition, and control this. So this is the pictorial diagram of the Bluetooth layer, that is the physical layer, data link layer, and this is what we are talking about, that they support the gap, they support the ATD, L2 cap is there. So all these are worried about how to control the host, how to make the connection and other things. And this bottom application layer, that is work intermediator between this and your application. So this is all about the Bluetooth. Now we can see that we already seen that this is working in the parallel, and these 2 protocols, they are worried about the connections and other things. So here physical layer is 2.4 GHz ISM band they support. Then data link layer, in place of data link layer, Bluetooth use the link management layer and L2 cap and other things, that layers. And whatever the presentation session transport network layer, that is they are using in terms of these layers, whatever the protocol sub layers are there, SCL, SMP, L2 cap, and SSD. And they also use the TCP and other thing for transmission of their application. So this type of architecture is the Bluetooth architecture or the model, and this is the OSI model compared with the OSI model in this way. Wireless, here is the another protocol which is also based on the 802.15.4, and the beauty of this one is also that is very lightweight and reliable, and that means the protocol that is secure because they use the encryption and other things. So wireless communication protocol based on highway addressing remote transition, here communication protocol. So they use for wireless, they use the wireless, otherwise they also support the other type of the communication medium. And bottom 2 layers is the 15.4, that means whatever the modulation technique and other things are there, whatever the gigahertz frequency band is there, that is also there. Here they support the mesh topology as compared to peer-to-peer topology in the Bluetooth. So this is the then beauty of this wireless HART protocol. They support the mesh topology. That means the numerous of devices they can connect with each other with using the mesh topology. And because of the mesh topology, that is also suitable for the harass industrial environment where the high level of the inference of obstacles or failure is there, so that at least one node can communicate to all nodes, or at least one node can communicate to other can communicate to other, so that finally you can find out the entire information because of the mesh topology. If one node is only connected with another one node peer to peer, then maybe possible some obstacle, some there's harass environment, some failure is there, you are not able to find out the information. So this is the beauty of this protocol. That means they support the mesh topology so that at least you have the information. And as we already seen that they support the encryption and authentication in so that this is a secure and reliable communication protocol. Similar as the Bluetooth and other that we have seen the protocol, they also have the 5-layer protocol architecture. Application layer working in between your application and the bottom layer. So this wireless here they design whatever that means requirement is there. Say for example they need the application layer, they design their device descriptive language, DD language, so that they can implement their application layer. For the network layer, they provide the network functionality for connections and other things, wireless network management protocol, NMP, they design only especially for the network company because they need a configuration and management both together. So that means they design their own protocol for communication purpose at the network layer. Now transportation layer for end-to-end communication for between the devices, they design the wireless air transport protocol, WTP. And because of their design, there are different protocol for each and every layer. They have the good control on that one. That means they can control the security, they can control the privacy, and for handshaking and other things. So they say the security and reliability both together, authentication and encryption is there. Because they have their own protocol each and every layer. Data link layer, they have the wireless data link layer protocols for error detection, for error correctness, packet routing and addressing. So it is very popular and powerful protocol, especially for wireless sensor networks. And the physical layer is that is wireless physical layers is there. This is the architecture of this one as compared to that Zigbee and other protocols. So Zigbee, they work in these 2 layers, the rest of the Zigbee. This is the OSI model. We can see the layer 1, 2, 3, 4, 5 layers is there. So this is the physical layer. This is the for the data link layer or the make layer. Since this is also somewhere this one, so they also use the 2.4 gigahertz transmission. Then they use the secure reliability comes into the picture, power optimization at the network layer, and auto segmentations and other things at the this one network layer and upper layer. So this is about the wireless communication protocol is wireless. Now we come to the Wi-Fi. Wi-Fi takes more energy as compared to these protocols, but they have a long communication range as compared to that one previous earlier protocols. So IEEE 802.11 you say, or you say refer as a Wi-Fi, both are the same. So standard basically they change that 802. They use some A, B, G, N, A, C, and A, F based on some their properties, based on some changes is there. So it is good we can use the 802.11 as in place of the Wi-Fi like this one. So while so that you can easily distinguish between this and that one. Otherwise it is very tough to distinguish. And this is also a standard for WLAN, and it is created by the IEEE. And they work on the 2.4 gigahertz, 5 gigahertz, even 16 gigahertz frequency bands also there. And what is the difference between these A, B, G, and 802.11? With the different specifications such as the data rate, which one is the high data rate, which one is the low data rate. Frequency band, which frequency band they use the 2.4 or 5 gigahertz, they can change with the help of ABGH. Channel width, whatever the channel bandwidth is there, modulation techniques and other features. So A is use the different frequency band, B use the different frequency band, like this one. That means if you use the different data rate, different frequency band, you can use the different A, B, G, and AC. So this is the 802.11 protocol stack. That this is similar as the OSI model. They also have 1, 2, 3, 4, 5 layers. Layer 5 to 7 is merged in the application layer. That means they are completely control on upper 3 layers. Rest of the things are the same. Data link layer is 802.11. Their physical layer that is ABGS is depend on your perimeter, but yes, that is a different as compared to previous one. Then data link layer, they have on their MAC layers, and now upper layer is the IP TCP layer, is the same as OSI model, and other 3 layers merged together. So here we can see that the difference, main difference is the this one. So they divide MAC layer in that means the second layer, data layer, into 2 sub layers, the MAC layer and the logical link control layer, so that they can make the connections and do all other local connections and responsibility. IP and TCP transport protocol is same as our OSI model in this that Wi-Fi, and application layer they support that means HTTP, FTP, SMTP, all these they are supporting perfectly in the 802.1 and Wi-Fi. Now we come to the LoRaWAN. This is the last one, long range communication protocol, and that covers the advantage of both. That means they consume a very less energy and they have a huge long distance. That means they can communicate up to some kilometers sort of things, not only 1 meter, and the lifetime is some years, 1 year, 2 years lifetime. But yes, they have the negative point is the data rate. Their very limited data rate is there, so you can transmit the sensitive data. You are not able to transmit some video, audio sort of things. Security point of view, this is the end-to-end encryption. So there are 2 types of the key in LoRaWAN. One is the application level, other one is the network layer. So network server, they share their key, application server, they share their key. So this is a completely encrypted and secure data transmission. We are not worried about this. Since that is scalable, large distance communication is possible. That means they support the thousands of the devices, and they also communicate huge distance. So scalability is also not a problem. And this is the open standard. That means it is not controlled by any company. You can change, you can modify the protocol whatever based on your requirement. It supports star of star topology, that all devices are connected with the gateway. Transmit, that means they also support the one-hop communication. All devices can directly communicate with the gateway, and they support the two-way communication. Device can communicate to the gateway, gateway can also communicate to the device, not only one-way communication. Geolocation, that means if you take some information, then they also support like geolocation. That means at which device, where is their location, and what they are working. And it is the cost effective. Why? Because we are not required the relay devices. You can directly communicate to the gateway. It's a 10 kilometer distance is more than sufficient to direct communication inside the campus like this one. So this is a smart home. They deploy some sensors and they have the LoRa devices. They can directly communicate with the LoRa gateway. So here the LoRaWAN protocol in between this. After that we use the normal protocol, whatever the protocol is there. Then not the LoRa protocol. LoRa protocol work in between. The nodes can communicate with this one. This is another pictorial diagram of the LoRaWAN. The nodes, they can communicate with the gateway, gateway communicate with the network server do something and show the result to the end user. So this is the application of the LoRaWAN. This is another application of the LoRaWAN in intelligent transportation system. Some vehicles are there, so they can detect, of course, if someone is moving perfectly or not, they are doing something wrong or not. This is the agriculture application, that where a cattle is enter inside the agriculture field. Then LoRa node can detect, they can transmit to the gateway, gateway can detect this information and generate the alert to the end user. These are some examples. So IIT-BHU Varanasi campus is right now the LoRa enabled. We set up our own LoRa gateway and LoRa network inside the campus, and this gateway is connected the chirp server initially. So you can see that this is the location. They show that okay, this is. So here this is the Think network server. They show the location. This black color dot indicate the gateway. So in India, this is the LoRa gateway at IIT-BHU Varanasi we set up. So you can see that most of the European countries, they use the LoRaWAN right now. They have their own gateway. They can communicate. They can use perfectly. So outside the India, that in the European country, they use the LoRaWAN perfectly to transmit the data to all these things. This red color indicate the region of the LoRaWAN in IIT-BHU. We tested that yes, it's working perfectly. This is the outdoor gateway shape that put on the roof of the Department of CSE. And this is the how we can check the region, that whether it is covered or not. We need to, how we can make this ring sort of thing. So if we cover some selected point, then we can draw this line that okay, this line is covered. That means whatever the point inside this region, that is covered by this LoRaWAN, whatever the LoRaWAN we have deployed. So you need to check manually and go and check these points. Then after you can make a region that okay, this region is covered by the LoRaWAN. So all these buildings that we have checked, that we have covered in this LoRaWAN network. So LoRaWAN is recently that find out a huge popularity in terms of the application, in terms of the energy, in terms of the cost. Finally, becomes that means a different subsection, that section. So numbers of network simulations exist for wireless sensor network, and these simulations helps to provide a real-time scenario. You can modify the protocol, you can work in a different protocols with a different aspect like this one. NS2, NS3 is very popular, OPNet, NetSim, and QSNet, and numbers of others. These are some examples. So if you want to work on one networking protocol or wireless sensor network protocol, if you want to modify, first you need to work in these simulators so that you can familiar with all the protocol stack or whatever the header files is there. Then after start work on the node so that we can familiar with the platform, and then we can jump on this one. So this is the last one that if I want to start the wireless sensor network programming, I am not familiar with the simulator, neither the node, how we can do. So if you are familiar with the Python, you can make some small program first, and then after you can jump to the network simulator and finally go to the node designing. So here I have written a one program in the Python for the node design. So one design one class node, and class node, they have the node ID and they generate some information between 0 to 20, whatever the information is there. If I read myself, read the value, then I am reading the value. If I that means send this or forward this information to other, I can call the send value. If I receive the information from other source, then I can call this function receive. Now I created 0, 1, 2, 3, 4, 5 nodes in the network here, and while true, jab tak network exists, whenever the network exists, you can transmit, you can receive the information. You can go each and every nodes, whatever the nodes you have defined, node IDs are there. Make some speed slow so that we can add some sleep time in this, and read the values, whatever the value randomly you have generated. And if I am not the destination, I can forward this information to the other. Here I have not decided the destination, so this, if you run this program on Google Colabs, then or the Python, anyone Python, then they can continuously working, because I am not able to find out the destination. So one node receive a value 20 from node 0, node 2 also receive, node 3 also receive, then node 2 receive the value from node 1. So each node they can transmit the values to each other. So this is a one toy example that how we can create the node, how we can transmit the value, how we can receive the value in wireless sensor network, and how we can write the program in Python programming for this. So this is all about from my side. Thank you very much for this.